Start by taking a geometry object and decrease the dimension by setting the numbers of rows and columns to 2. Next, generate the point from volume and set the point separation to 0.4. Set ISO value 1.4. Then use the cluster point node to create clusters, setting the cluster size to 75 or any number you prefer. Similarly, set the number of iteration to 11 or any number you like. Take Houdini fracture node and connect it to the second input, and the first input will be connected to the grid. In a Houdini fracture node, enable the copy cell points attributes option. Set it to the CD and cluster for the piece primitives. Add for each piece node and to process each fracture piece individually. And remove the connectivity. Inside the loop, add fuse node. At the end of process, ensure that the piece attribute is set to cluster for each fracture pieces. Use explode view node to visualize the individual pieces of geometry. Ensure that the piece attribute is set to cluster so that each pieces can be identified by its respectively cluster. Add an angler node to create mass using wax expression. Start by floating variable called distance and set its absolute value of @p.x minus with our custom channel offset. Using the if statement, distance less than our custom width and multiply by 0.5. If it's true, @CD will be 0. Hit the compiler. Set the width for my sim is 0.8. Use keyframe the offset to move from left to right. Transition from negative position to positive. Use attribute promote node to change the attribute class from points to primitives. Set the original name to CD and specify the new attribute name as Z-scale. Now add a polyextrude. Enable the local control in polyextrude settings. Enable the Z-scale option from distance scaling. And set the distance to 1.